So let's look at conditional branches. So conditional branches are actually also using the I format. So in machine language, we only have these instructions. So we have 6 machine language conditional branch instructions. So basically all this BQ and BNE and all that we saw before, there are only 6 of them that are machine language. So you have your 2 registers. For some of these are dealing with 0. So they have only 1 register. And the last argument is the I. So it still is 16-bit. And this 16-bit I is basically giving some information on the target address, or BTA, or branch target address. And we're going to look at that in more depth. So if you want to, we said, so these are the 6 that we saw. So these are the 6. So between assembly and machine language, there are actually no difference. So it's the same thing. If you write that and assemble, you're gonna get the same thing. For some of them, that for example, you have BQZ, so that was branch equal to 0. So when you write assembly like that, in machine language, you're gonna get basically that replaced with the BQ, which we have here, BQ, and this is going to be replaced with register 0 or just 0. And same thing as branch not equal. So this is branch not equal to Z. So you're saying this is not 0. And this is going to be translated to branch not equal, your same register that you had, and then the register 0. So that's that. And you have your I. So same as basically that is going to be some hints about the target that we're going to see. For other instruction that we've seen, so there was more than this. For other ones, we are actually using this set less than or SLT instruction. So that is basically going to help us to convert the other ones to one of these 6 instructions. So how does it work? So let's look at this one. So we have set less than. So let's do, for example, in our like S0 and S1 and S2. So it's gonna check if this one is less than that. So it's going to check if S0 is less than S2. So let's say like there is 5 and then there is 10. So if 5 is less than 10, so if it is true, then this one, S0, going to be 1. So if S1 is less than S2, then S0 is equal to be 1. So it's just a flag, kind of. So only it's gonna become 1. Else, that S0 is going to be 0. So basically, just check less than. So if this is less than that, set S0 to 1. If it's not, set it to 0. So that's the basic instruction here. We have also another version that it's set less than I, and it's exactly the same thing with the exception that instead of doing this second register here, we are actually putting the number. So you can put, for example, set less than I, S0, S1, and 10. So if S1 is less than 10, S0 is equal to 1, else you are putting S0 to 0. So this is like 2 variation of this same instruction. And we are going to use this to convert that other branch instruction that don't have direct translation to machine language to machine language. So we are going to see how. So let's look at the next slide. So here These are actually very tricky when you look at them. But let's look at this first one, for example. So branch less than. So first of all, before I look at that, I want to show you again this table. So for branch, so this was the instruction that we had. We said they are same in machine language. So we don't actually have branch less than. You see, there is no branch less than. We have branch less than 0. So that's something we could use, or maybe greater than 0, but we don't have directly branch less than. So when you do branch less than, and you're having 2 registers and a label, actually the machine language is going to be this code. So first of all, the label, I just want to get something out of the way. So the label somehow is going to be translated to this I. So we're gonna talk about that later. So that's something that we're gonna calculate. But just take it as that this label, so this could be like array or like, I don't know, loop, something that we see before. So this label somehow is going to be converted to a number, and that is not our concern right now. So with that out of the way, so this is checking that register 13 is less than register 17. So this is actually going to be translated to this code. So it's gonna be translated to set less than. We have that register 1 here as our kind of like a helper. So if 13 is less than 17, then register 1 is equal to be 1. Else, register 1 is equal to 0. So first we are checking that, kind of the same condition. And if that is true, we are putting the flag in register 1. So 1 going to be either 1 or 0. And then we are using a not equal. So branch not equal. If register 1 is not to 0, not equal to 0, so this register 0 is hard coded to 0, then we'll jump. So let's look at that. So when is that these two are not equal? So if they are not equal, so that means, because this is always 0, so that means if they are not equal, then that means this is not 0, and that's the only case is 1. So then that means we are here. So that was our true case. So here also we're gonna be true if they are not equal. So we're gonna jump. If they are equal, we are not going to jump. Because what does it mean if they are equal? That means they are 0. So if those two are 0, that means we got here, because this 1 was equal to 0 here, and that means this 13 was not less than 17. And that means if this 13 is not less than 17, this is false, so we're not gonna jump. So basically you see how that here, we converted the whole thing into this 2 instruction without having another instruction for this. So we are basically reusing other instruction to achieve this branch. So here you see other kind of like other translation that he had, and it's actually a really good exercise to try to figure each of them. And it could get a bit of challenging, but it's a very good exercise to basically let you think about the logical operation and how this works. But basically all of them works the same way. We are first doing a condition check, and then we are using another thing to check if that result of that condition is equal or not equal to 0, and then we do the jump. So some of them get tricky. For example, here we have a greater than, but here we are doing a less than. But then sometimes like so for example, here you see it's 13 and 17, but here is flipped. So you see there is kind of smart ways to achieve this, and all of them can be proven actually like mathematically. So it's all like provable. It's not that it's like approximate. So there is like 100% valid translations.